So let's make a puzzle file from scratch. I decided I'm going to make the Skewb because it's relatively simple, but it will still show the principles on how to make the puzzle. Let's go into SolidWorks for a second. I made this mock-up very quickly. This is actually all just one single body, as you can see, just one solid body. I just have these split lines on here so that what we can do is we can measure from the origin to a point and get our values. I'm going to have the scaling factor on this be 100 because I made this cube be, actually sorry, I'll have the scaling factor be 50 because I made this cube 100 by 100, and from the origin outwards in any of the three directions the largest value is 50. So I'll set the scaling factor as 50. Right there, 50. Okay, that's one of the 9 pieces of information done already. Okay, now we need to do the face data. Okay, so there are 6 different faces on this puzzle, and they're all identical. So let's use that to our advantage. Let's do something very similar to how we did in Cube 333, but in Skewb. So first let's treat this like a black box. Nothing in there. But the second, third, fourth, fifth, and sixth faces are going to be just translations and rotations, or actually just rotations, of the first face. So the first face will be the front face right here. Actually, no, that's not true. The first face will be this front face, because in my simulator I have Y as pointing up, X as to the right, and Z as towards the screen, or towards the user. Okay, so these should be the same as the rotations in Cube 333. So now what should actually go inside of this? What should go inside the first face? Well, again, let's treat everything like a black box. So let's start by not making the first sticker, but let's make the other stickers first. So the first sticker, let's say the first sticker will be the square in front. Okay? Well, there's no other squares, so then the second sticker is going to have to be one of the triangles. So the second sticker will have to be a triangle. Then the third sticker, fourth, and fifth, because there's only 5 stickers, will just be translations of the triangle, or rotations of the triangle. Okay. So this is going to be the structure of our first face. So let's first make the square. So the square has 4 points. And there's 2 ways that you can do this, but let's start with the first point. Origin to here is going to give us, it's going to be 0 in the x, 50 in the y, 50 in the z. Okay. Yes. So it'll be, so inside the first sticker, it'll be 0 in the x, 50 in the y, 50 in the z. Okay, now what I can do is I can define the other 3 points of this square explicitly, or I can define them relatively. So let's define them relatively to try that out. So here I did translations of it, and I can do translations or I can do rotations. In fact, let's try doing a rotation and let's see if it works. It might actually not work, but let's have an experiment here. So I'm going to want to be rotating this point by 90 degrees about the z-axis. So I'll want to rotate it about the z-axis by 90 degrees. And this is going to be our second point. Okay. Our third point is going to be very similar, but it's going to be about the z-axis by 180 degrees, and then 270 degrees. And that should be the square. Again, we don't really have any way to test this until we finish the entire puzzle file, so hopefully everything works out. I'm actually doing this for the first time while I'm recording. Let's do the triangle now. The triangle can start off with this same point. Let's do the top left triangle to start with. So that'll be this same point we'll start out with, this point right here. Then we can take this point and we can translate it by 50 units in the negative x direction. So let's do that. Let's translate it by 50 units in the negative x direction. Okay? And then this one is going to be translated by 50 units in the negative x and 50 units in the negative y. And that should be our triangle. Now let's make triangle number 2 be this one right here. So that means we're going to rotate around the z-axis by minus 90 degrees. And the reason it's minus 90 degrees is because I'm using a right-handed coordinate system, which means that if you stick You know, if I was recording my hand, this would be a lot easier. In fact, I don't really know if I can explain it just with words. It would be good to look up what a right-hand coordinate system is, though. But I'll just use the word for now, assuming that you know what I'm talking about. Oops. So for the second triangle, I will make it, I think I said in the Z direction by -90. Okay, so that'll be the second sticker. Then the third sticker, I'll make it this bottom left one right here. So it'll be in the Z direction by 90. That's positive 90. Actually, that was very helpful to have. Okay, and then this last one, this last triangle right here is going to be in the Z direction by 180 degrees. Okay, and that's our first face. And in fact, that's not just our first face, that's the entirety of all of the faces. So this should all work out. If it doesn't, I will try to figure out what went wrong. So I like to move all this onto one line now that we understand how it all works. I could take away all the spaces here, but I don't really have to because the spaces don't really affect the code at all. It might make it a bit wider on the screen, but that's okay. Okay, now I need the third piece of data, the colors. I'll just use the same colors as on the 3x3 because it's a cube and it has the same exterior geometry, so that's okay. I can do that. Same with the normals, in fact. Okay, now we need to get into these right here. So let's start off by just making the first move. So the first move, let's make it along right here. Do I have a plane? That's not the right plane. Let's make a plane. Okay, so this plane right here, this is the plane that I want the move to be. Let's, right there. I want it to turn this. So I want it to turn all of that. So these stickers are stickers 1, 2, 3, and 5 on the first face. This face right here is face 5. This is sticker 1, 3, 4, 5. This is face 3 with stickers 1, 2, 3, and 4. And then the other 3 stickers, I'll figure it out when I get there. Okay, well, let's set up the structure to start with. So there are 6 faces. Each face has within it 5 pieces, 5 stickers. And in fact, I should have done the copy afterwards. Oops. Okay, so this is the structure that it's going to look like. Okay, let's just make one move for now. Well, let's add the other moves in later. Let's make just this first move. So let's say for move number 1, and move number 1, let's call it using the 1 key, just the 1 key. And that's not the numpad one, but just the normal one. It's going to rotate around the 1, 1, 1 axis, which is going from the origin to this point right here. Oops, going from the origin to this point right here, that's the 1, 1, 1 axis. So it goes on the 1, 1, 1 axis by 120 degrees. Okay, to make this actually work with only one move, I'm going to have to put commas after this. And then the permutations, I believe that we don't need it for now. So for now, let's just do 1, 2, 3, 4, 5, 6, 7, 8. Because there are going to be 8 moves eventually, but not quite yet. This is not exactly a short process, but I find it pretty rewarding. So this is sticker 1 on face 1, which is right here, and it can be turned by the 1 move. Okay. So can stickers 2, 3, and 5. Stickers 2, oops, 2, 3, and 5. Okay. What about on the 2 face, which is the back face? So on the back face, the way we rotated it, we actually rotated it, let's see, we rotated, around the y-axis by 180 degrees. So we went around like this. So this means that this sticker, this is 1, 2, 3, 4, 5, so this is sticker 2. So sticker 2 on the 2 face can be rotated. Okay. Now let's try the 3 face. This is sticker 1, 2, 3. That's sticker 3 on the 3 face. Oops, that's not the 3 face. Nope, that's the 4 face. This is the 3 face. 1, 2, 3, 4 on the 3 face can be rotated. On the 4 face, it's just sticker 3. On the 5 face, it's 1, 3, 4, 5. 1, 3, 4, 5. And on the 6 face, it's just sticker 2. Okay. This may or may not work. Oh, there shouldn't be a comma there. This may or may not work. Let's try it out and see what happens. So let's add Skewb to this. Oops. Because I named the file skewb.txt. So that'll be number 4 in that names. And let's see what happens. Oh look, there it is. We just made this. Just now. So what happens if I click the 1 key? Oh look, it rotates. Oh, but it doesn't rotate properly. So I must have gotten my naming convention with all the stickers wrong. But that's okay. So let's try to troubleshoot this, because this does happen when you're making a puzzle. So if I hit the 1 key, it rotates all the pieces that are on these 3 faces correctly. But it doesn't, oh, so it does take this one correctly. And it does take the green one correctly. It just doesn't take the white one correctly. So the white one is face number 6. So how did I move face 6? I got face 6 around the x-axis by 90 degrees. Meaning that this would be, oh, that's not sticker 2, that's sticker 3. Oops. Okay, now it looks good. So I can make this full screen. And there it is. That's our first move on the Skewb. And that was made just out of that text that I just wrote. If I hold down Shift and hit 1, it goes the other direction, of course. Okay. And now all we have left to do is program in the rest of these. And program in the permutations. Let's program in the permutations first. So let's call this point, or the axis that goes through, the move that goes through this point, let's call it 1, as we already did. Let's call the one that's opposite it 2, just to make everything easier. Then we'll call this one 3. I should really be writing this down. This is not going to go over very well. I should be calling this one 3. I should be calling this one 4. 5, 6, 7, and 8. And why am I doing it specifically like this? Just so I can have opposite pairs be neighboring numbers. I don't think it really matters. This is actually just, I mean, it's really just a random naming convention. It doesn't really matter. Okay. So we'll start off by saying that when you rotate around the 1 move, 2 stays where it is, right? Everything that can be turned by 2 stays where it is. But this was 3. 3 goes to 5. 5 goes to 7. 7 goes to 3. Okay. So 3 goes to... Actually, now it comes into play what happened over here. Let's try it like this. It might not work that way. So 3 goes to 5. 5 goes to 7. 7 goes to 3. And then as well, these ones also matter. So this one, or this one right here is 4 goes to 6 goes to 8. 4 goes to 6, which goes to 8, which goes to 4. Okay. I actually don't know if this works until I add in a second move. So let's add in a second move. That'll be 2. Actually, no. even once I add in the second move, it's still not going to be, because the second move is opposite the first move. But let's do that anyway. So we'll add in the second move, which rotates around the -1, -1, -1 axis, which is the same as the 1, 1, 1 axis, but doesn't really matter, by 120 degrees. Okay, this one should in fact be exactly opposite. This permutation should be exactly opposite as this one. Yeah, it should be. So this one should be 7, 3, 5, 8, 4, 6. And again, we don't really know if this works until I make a third move. So, oh, plus, yeah, this makes it a little bit simpler. Every move that can be rotated by one cannot, every sticker that can be rotated by one cannot be rotated by two, and vice versa. So 2, 2, 2, 2, 2, and then we'll test it with the 2s. Okay, now let's check if all this works. Oops, why is it so high up there? Okay. You know what, I'm going to change the screen size. Actually, it doesn't matter. So, 1 turns all this, and 2 should turn exactly everything else. Perfect. And it works. Great. So if I hit scramble, it will randomly choose to be turning these two moves. It's not really that impressive of a scramble. Nothing's really scrambled. You can solve it in a couple seconds, if even a couple seconds. So let's now add in move 3 and see if all of our permu worked. We'll add in move 3, which is going to be this one right here. So this one, let's just measure everything. Actually, I don't think measuring is going to work. This goes in the negative x direction, but in the positive y direction and the positive z direction. So it's going to be -1, 1, 1. Again, everything here is 120 degrees. And what can be rotated by this one? So let's remove this plane and let's add in a new plane. Oops, not that one. Let's add in a new plane right here. Let's see. So from face 1, stickers 1, 2, 3, and 4 can be rotated. So stickers 1, 2, 3, and 4 can be rotated, meaning that move 4 is going to be rotated by this one. Or sorry, we'll rotate this sticker. So let's add in move 4 simultaneously because it's simple to do. And then its axis is going to be the same. In fact, I could add the axis in a different way. I could just do -120 with the same. But I prefer to leave all of my rotations to be positive and then switch the sign on the axis. Okay. From face 2, only sticker 3. Only sticker 3. What about from face 3? From face 3, only sticker 1. Or that's 2 actually. Only sticker 2. Face 4, which is this one, gives 1, 2, 3, 5. Oops. 1, 2, 3, 5. And again, as I said, I'm adding in the 4s to the ones that aren't 3s. On face 5, which is the upper one, it's 1, 2, 4, 5. 1, 2, 4, 5. And then on the bottom one, it's just 2. So it's just 2. Okay, and this should work now. Oh, nope, not true. Ha. We need to fix the permu at the bottom. So let's write a new one. 1, 2, 3, 4, 5, 6, 7, 8. Just makes it easier. Oops. Okay. So axis 3 and 4 stay where they are. 1, when you do a 3 move, 1 goes around and hits. Oh, what did I call that now? I called that 6. Because it was 1, 3, 5, 7? Yes. So that's 6. So 1 goes to hit... 1 hits 6, which hits 8. 6 hits 8. 8 hits 1. Okay. And then 2, which is this one, goes around and hits whatever's the opposite of 6, I guess 5. 2 hits 5. 5 hits 7, and 7 hits 2. And 3 and 4 stay where they are. That should be right. Okay, so now I just have to reverse everything. So instead of 6, 8, 1, it's going to be 8, 1, 6. And the only reason I'm reversing is because the move is exactly opposite. And instead of 5, 7, 2, it's going to be 7, 2, 5. This should work, hopefully. So 3 rotates that. Nice. And then 4 rotates that. Okay. This is going to get a little boring. I think I might just do it all here, just in case anybody is interested to watch the entire thing. It might be very boring, but then again, a lot of people are very boring. So some people might call me one of those. So now we want to rotate around 5. That one's 5. Let's make a plane right here, here. It's very easy to visualize things in SolidWorks because SolidWorks is a very visual program. I couldn't really... I mean, these numbers, really, they don't mean anything if you just look at them. I mean, I can't look at this and automatically think, oh, look, it's a Skewb. There's no way I would know that. It's SolidWorks, which, you know, helps me visualize everything. Okay. So... Move 5. What can be turned by move 5? On face 1, it's sticker 3, meaning that 6 can be doing the other ones. Face 2, it's 1, 2, 3, 4. So that's 1, 2, 3... Nope. 4, and then 6. On face 3, which is this one, 1, 2, 3, 5. So you get 1, 2, 3, not 4, but 5. On face 4, it's only sticker 2. Face 4 is only sticker 2. Face 5, which is the top one, 1, 2, 3, 5. So 1, 2, 3, not 4, but 5. And then 6 is going to be just sticker 1, 2, 3, 4, 5. So 6 is just sticker 5. So all the other ones are 6s. Actually, I'll leave these out for now, just in case I want to test. This axis right here is positive x, positive y, negative z. So that's positive x, positive y, negative z. And then the other axis is going to be exactly opposite. Okay, and now the permu, the fun part. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so when you turn around 5, this is 1. 1 goes here, which is 8, because that's 1, 3, 5, 7. So 1 goes to 8? No, that can't be right. Oh, yeah, that can be right. Yes, okay. So 1 goes to 8, which goes to 4. 1 goes to 8. 8 goes to 4. 4 goes to 1. And then this is 3. 3 goes to this one, which is 2. And 2 goes to 7. So 3 goes to 2, 2 goes to 7, and 7 goes to 3, leaving 5 and 6 unchanged as they should be. Okay. And then I'll just copy this one. I don't know why I made 2. So instead of 8, 1, 4, it'll be 4, 8, 1. Instead of 7, 2, 3, it'll be 3, 7, 2. Let's test. So that should be move 5 right here, and move 6. Okay. Last one. Last one. So that, let's make one last plane right here. This plane is going to be here, no, here, here. Because that one is 7, yeah. So 7 is this one, so it's 1, 3, 4, 5. 1, not 2, but 3, 4, 5. On face 2, it's just 1, 2, 3, 4. Face 2, it is just 4. And again, I'm putting the 8s where it's not 7, just because it's a Skewb and it's completely symmetrical. Okay, face 3 can be turned by 1, 2, 4, 5. 1, 2, not 3, but 4, 5. This is face 4, can be turned by 1, 2, 3, only 5. So that's only 5. Face 5, which is the top one, can be turned by only, sorry, can only sticker 1, 2, 3, again 5. So again, that's only 5. 2, 3, 4, only 5. And then face 6, which is the bottom one, 1, 2, 3, not 4, but 5. 1, 2, 3, not 4, but 5. It's going to be around the axis of, in the positive x, negative y, positive z. That's positive x, negative y, positive z. And then the axis below it is going to be a copy of that, but negated. Okay, last permu. So 1 goes to, that's 4, which goes to 6. 1 goes to 4, 4 goes to 6, 6 goes to 1. This one right here is 3, goes to 5, goes to 2. So 3 goes to 5, which goes to 2, which goes back to 3. Is that what I said? Yeah. Copy it and reverse it. So 4, 6, 1. It's going to be 6, 1, 4, and then 3, 5, 2 is going to be 5, 2, 3. And this should be the entire Skewb. Let's see. So that's move 1, move 2, move 3, move 4, move 5, move 6, move 7, and move 8. Okay. So, I hope nobody found that too boring. I mean, obviously it's a little bit boring, but the concepts are exciting. I hope, at least. I hope there's at least one person still watching. Well, that person's probably me. So I guess I'll just end this off with Scramble, in case anybody is interested. This is our Skewb. Oh, haha. Everything messed up. Okay. Okay, well, I guess I have something to work on. Ha. But until then, so thank you. Thanks for paying attention. So just as a quick side note, I figured out what was the problem. I actually had the entire setup of the permu wrong. If 1 goes to 8, it's actually... if 1 goes to 8, 8 would actually have a 1 on it. So I just took these and flipped them around, so I made this one be this one and vice versa, and then every pair I just swapped them, only because they're opposites. That wouldn't always work. But this one doesn't mean that 8 goes to 1. This one actually means that 1 goes to 8. And then 8 goes to 6, and 6 goes to 1. So I hope that didn't confuse anybody, but now it is working. Now I will actually properly end this off with a proper scramble. Let's zoom in, make this... Oh, no, let's zoom in, make this very nice. And there it is. There is the working Skewb, finally, after all this time. Thank you very much.